Hi, this is Nathan Tintle. In this Learning Goal video, we'll talk about the correlation coefficient and how it responds to extreme observations. We will use the exam times and scores data set to talk about this learning goal. In the graph on the left, we show you the data as it was originally presented to you. Here, the correlation is negative 0.56 between the time it took students on the exam and their exam score. In the real data set, there were a few students who took a long time and did well. You can see that in the graph on the right, up here in the upper right-hand corner. We had students who took nearly 100 minutes and scored very well on the exam. With these few extra points added, we see that the correlation coefficient changes rather substantially, from negative 0.56 all the way to negative 0.12, moving from a moderately strong negative correlation to a very weak negative correlation. The addition of only a few students who took a long time and did well has radically changed the correlation coefficient. This is an example of how extreme observations oftentimes have a large impact on the correlation coefficient. So what should you do in practice? Always look at the scatter plot before you interpret the correlation coefficient. You're looking both for nonlinearity, that is some sort of curvature. You're also looking for potential and unusual observations. If you have unusual sort of outlier observations, extreme values, consider deleting them from the data set, recomputing the correlation coefficient, and seeing how much of an impact they have. Context, that is, what is the goal of your research, what is the research area, will then determine your next steps.